So this problem is a problem about sequences of numbers. So when you have a sequence, it's like a list, but there's a pattern involved. So in this case, it's 6, 10, 14, 18, 22, 26. There is some sort of pattern, and this specifies that the pattern continues adding the same number each time. So there's actually kind of a hit here. We're adding a number. And the question is, what is that number? So let's just think for a second. If I go from 6 to 10, what did I add? Well, I added whatever 10 minus 6 is, right? I added 4. Let's see, does that work? If I do 10 to 14, if I add 4 to 10, do I get 14? Bingo. If I add 4 to 14, do I get 18? Bingo. And you can see that the same thing is going to happen. So now what I want to do is I want to write a rule that can be used to find any number in the pattern after the first number, okay? So I know I want to start with 6, and I know I want to keep adding 4 every single time. So what I am going to have to do is introduce a variable that's going to stand for where I'm at in the sequence, right? So let's say that variable is n, okay? And what I want is I want n to be bigger than or equal to 1. And where n equals 1, I want to be at the number 6, right? So you could maybe think about creating like a table, right? Like if n is 1, I want to be at 6. Okay, we'll just call this P for pattern. If n is 2, I want to be at 10. If n is 3, I want to be at 14. If n is 4, I want to be at 18. You can just keep on going. And whatever the rule is, we need to check it against this sort of table that we've created. So what do I want to do? Well, anytime n goes up 1, I want to add 4. So this is kind of like a slope, right? You increase, you go to the right 1 and you add 4. So what if I treat it like a slope and I do 4 times n? I do 4 times n, okay? Well, if n equals 1, then that's just 4. Okay, if n equals 2, then it's 8. Okay, if n equals 3, then that's 12. That's not going to give me exactly what my pattern of numbers is. But one thing I haven't taken into consideration as I've started to make this rule is that number 6. I'm starting at 6, right? Well, if I'm going to start at 6, then maybe I should just have that 6 here, right? So I want to start at 6, and then I want to add 4 every single time, right? Okay, so let's try this out. If n is 1, then what is happening? Well, if n is 1, then I have 6 plus 4 times 1, which is 10. Oh no, that's not what I wanted. I didn't want to start with 10. So what's happening? Well, what's happening is I don't want to add 4 yet when n equals 1. And so what I need to do is I need to kind of back up 1 in terms of when I multiply by 4 and add that. So now let's try again. So if n is equal to 1, I do 6 plus 4 times 1 minus 1, which is 6 plus 4 times 0, which is 6 plus 0, which is 6. Great, got it. And now what we could do is we could go on and check. If I plug in 2, I have 6 plus 4 times. If I plug in 2, I have 2 minus 1, which is 1, right? So I'm doing 6 plus 4, which is 10, and so I've got what I want. And you can go on and you can keep on seeing that this is going to be the pattern, okay? So just kind of standing back and looking at it, we had to have this original number, the starting number, taking consideration, and then you add whatever you're adding each time multiplied by something involving this n. And then what goes in the parentheses here is ultimately determined by where you want that n to start. And we want it to start at 1, and so that's why we end up having an n minus 1.